the 10 counters, each with a number on it, are turned over so that the number is not visible and mixed up. Nathan picks a counter and reveals its number. He then picks a second counter and reveals its number. A. Calculate the probability that the number 4 is on both counters. And B. Calculate the probability that the sum of the numbers is divisible by 2. So the probability of getting a number 4 on the first pick, well, there are 4 of them out of 10, so we'll just leave that as 4 out of 10. The probability of getting a number 4 on the second pick, well, if you've already taken one, then there are only now 9 to choose from, and there are only now 3 which are a 4, so that will be 3 out of 9. These two events are dependent events, so the probability of number 4 on both counters will be 4 out of 10 times 3 out of 9. There's a bit of counting we can do here. 2 goes into 10 5 times, and then into 4 2 times, into 3 1 time, and into 9 3 times. So that's going to give 2 times 1, which is 2, and 3 times 5, which is 15. So it gives an answer 2 over 15. Right, in the second case, we have to calculate the probability that the sum of the numbers that we choose is divisible by 2. So therefore, we're going to need to consider all the possibilities. So drawing a tree diagram, so we have the first pick and the second pick, and then for the first pick, we can get a 3, 4, and 7. All the probabilities out of 10. There's 3 ways we can get a 3. There are 4 ways of getting a 4, and then 3 ways of getting a 10. Do not cancel down when you're making this tree diagram. In the second pick, then having got a 3 on the first go, we can get a 3, 4, 7. Having got a 4, we can get a 3, 4, or 7. And having got a 7, we can get a 3, 4, or 7. All the probabilities are going to be out of 9 with one of the counters we've already turned over. Right, so if we've taken a 3 from here, there are only now 2 left from here, and these 2 are now the same, 4 and 3. This one will be 3, and then we've taken a 4 from here, so this will be a 3, and we still have 3 7s that we can choose from. Here we have taken a 7, so there will be still 3 ways of getting a 3 and 4 ways of getting a 4, but only 2 ways of getting a 7. Then working out the sum and the probability. So 3 plus 3 makes, here we get the probability of 6. So we consider the sum, so it's 3 tenths times 2 ninths, which is 4 6/90ths. Here we're going to get 7. So that's going to give me 12/90ths. Don't cancel these down because you're going to have to add them up. And then here we're now going to get a 10, a 7, a 8, 11, a 10, a 11, and a 14. Right, how do we get, we want the probability of the sum that is divisible by 2. So any even number here, we need to consider. So that's that one. We'll need to consider that one. We will need to consider this one. We will need to consider this one. And we will need to consider this one. So we need to add those probabilities together because all these events are considered to be mutually exclusive. So if you leave them out of 90, it makes it easy to do. So 6 out of 90, 9 out of 90, plus 12 out of 90, plus 9 out of 90, plus 6 out of 90. That's going to give me 42 out of 90, which cancels down to 7 over 15. Okay, so it's been a video to show you how to calculate probabilities when you are given 10 counters and you have to reveal 2 of them, one after the other. I hope you've understood, and I thank you very much for watching.